Good morning, students. In today's class, we'll just discuss what is actually the meaning of laser, and we are actually starting the unit 5. That is, we'll start with the laser. So, in the unit 5, there are two chapters. That is chapter 1, which deals with the laser, and chapter 2, which deals with the optical fiber. So, in this particular two chapters, an engineering student should know the basic concepts of the lasers and how these lasers can be utilized for various applications and for different R&D work, industrial and manufacturing purpose, where actually we'll use the laser, and how this laser serves as a what you can say a medium of communication from one end to the another end for larger distances covered. So that will deal with the optical fiber, that is chapter 2, right? So now in the laser, actually you already studied this laser in the 10th class already. So in the 10th class you just studied about the basic of laser, and I think that you had a very clear idea regarding the laser acronym. What is L stands for, A stands for, S stands for, E and R stand for, and then we just start with the basic phenomena of different absorptions and emissions, and the later section will deal with the what you can say the important parameters which are required to produce any laser, right? And we'll start with the different types of laser, that is solid lasers, right, and the gaseous laser and semiconductor laser. So here in solid laser we'll just deal with the starting point, that is ruby laser, and gas for gaseous we'll just deal with helium neon laser, and so on, helium neon laser, and also we'll deal with the semiconductor laser. So now, what are the different applications of these laser for engineering purpose and for the daily purpose also, where actually we'll use this lasers, right? So here, and we just start with our today's class with the expansion of this laser. What is actually L? L is light. A is what? Amplification. So light amplification by stimulated emission of radiation. So which has been actually this particular aspect has been explained to us by Gordon Gert, right? So now this is the scientist who has given us the information regarding the laser full forms, right? So now we'll just deal with we started with the light. See, light. So you already know that light doesn't require any material medium to travel from one end to the another item. It doesn't require any material medium, right? In the normal air or glass or water, light travel without any disturbance, right? And in vacuum also light is traveling. So this is the important aspect of the light. So when we just talk about amplification, so whatever the light signal has been given to you, that light can be amplified. So we just say that is called amplification. And S, here say S stands for stimulated. So stimulated, what is the meaning of stimulated? So here actually stimulated emission, right? So you just say that stimulated emission, this is one type of emission, and which is the basic criteria or the basic principle on which the laser is working, right? So these light is radiating, right? So we just call this that emission of the light, that is come under the what you can say broad aspect. We just call that thing as the radiation. So laser, now we just call that laser as the light amplification by stimulated emission of radiation, right? So now the important characteristics of laser, this already you studied in your lower classes also. So here also we'll just have a very quick what you can say review about the characteristics of the laser. So in the first session we'll just discuss about the important characteristic of laser. So that is a monochromaticity. When I say mono is single, chromatic is color. So single colored, right? Or we just say that it emit only one wavelength, right? In a normal what you can say In a physics language, we just say that it is emitting a single wavelength. And when we just go for an what you can say normal English, mono is single and chromatic is color. So monochromatic, this is one of the most important characteristic of the laser. The first important characteristic of laser is monochromaticity, that is single wavelength. The laser is having single wavelength. It is emitting only a single colored light. And also when we just go to the next aspect, right? So before that we just have discussion regarding how this laser light is different from the normal light, non-monochromatic light, that the normal convention light sources what we use in our homes, right? In our homes we'll just use the non-monochromatic source of light. So this non-monochromatic source of light which actually we'll use in our home, so that is right, the light will be emitted in all the directions. And so here the light is emitted in a particular single direction. So we just say that this is called monochromaticity, that is single colored light. Coherent, so the important property, the second important property of laser is coherent. So what is the meaning of coherent? So the coherent is nothing but when the what you can say, they are the particular light ray, the two different types of waves which are exactly in same phase, or we say that in a single phase. So we just will call that particular light as the coherent light source. So coherent is nothing but the two waves, right? Now here we are just talking about the light ray, right? So when you talk about a light ray, so light rays, let us consider the two light rays are there. So they are having the single same phases. They are exhibited by they are traveling in the same direction, and with their travel within the same phase, right? So we'll just say that is called the coherent light. So this is the coherent property is a unique property which is existed by the which is actually there in the laser source. And the normally what we see in a conventional light source, they are called non-coherent light sources, right? The next important characteristic of the laser is a polarized, right? It is a polarized. So what is the meaning of polarization? You already studied. Polarization is making the what you can say, let us consider there are two components, right? You just studied in the intermediate also. The unpolarized light ray is having two components, arrow-headed and the dot components. Now if we just make the polarized means making one of the component, right, is what you can say, you are filtering. What we are doing is that removing that one component, right? So physically, not physically, what we are saying that if we just remove the component, either it be dot components from the unpolarized light ray, so only one type of component will be available in the right in the laser. So we just say that it's called polarized, that is called one plane, which is easy to pass through the media and which is having very high, and this is the important property which is laser is exhibited. Normal conventional light ray, we'll just say that is called unpolarized light. So you see here, what we have done is that we have just started with monochromaticity, and we just compared this monochromaticity of the laser light and the conventional light. Coherent for the laser light, and for the what you can say the conventional light and the laser light. Polarization is possible in the normal light, in unpolarized light ray, which we will use, which is there in the what you can say conventional light sources. So polarized light, this laser light is also known as the polarized light, and the important aspect is high directionality. So high directionality, it is in a particular one direction, and the light ray will travel in a particular direction and it will not spread. And the speed that see, when I say directionality means it is moving with a very high speed, and the width, or we can say angular speed, right? So when it is moving very high speed, the angular speed, we just say that it is of very small, that is 1 millimeter so per meter, right? For example, the light ray is traveling in for a 1 meter, so the width will be only a single millimeter. And also we say that it will have a very high intensity. High intensity, definitely the light ray will have a very high intensity, and high intensity means it can focus over a small, very small area. The intensity will be very high when compared with the normal conventional light source. So you can just see this. These are the important what you can say properties of the laser light, and when it is compared with the normal light, what will happen is the intensity, as the distance is increasing, so the intensity will be lost in the normal or conventional light source. But for the laser light, so you'll find that the intensity will be very high. Now, so what is the meaning of this? Einstein has given us the theory regarding the explanation of the actual action of the laser beam. So whatever you are studying about the laser beam, so it is actually based on the concept of quantum theory of light. So we'll just say that the action of laser is being explained on the basis of quantum theory of the light, and the production of the laser light is a particular what you can say the importance, how this light has been produced due to the interaction of this radiation with the matter. So we just study that the laser light, how the laser light can be produced. So the laser light can be produced, right, by the interaction of the radiation with respect to the matter. So when you interact the the radiation is interacting with respect to the matter. So what will happen is that we'll get what you can say the laser light has been produced to the, and see generally what we say that when the light radiation is interacting, right, with the matter, different processes are taking place. Either it will be emission or absorption. So now this is done on the basis of, so in order to study it very clearly, see what we are doing, that we are just taking the help of the energy levels of the concerned system for which the light is to be obtained, right. Now, so whenever the matter is interacted with the radiation, there are three possible ways through which the interaction of radiation and matter can take place. So now that is called the induced absorption, and the spontaneous emission, and the stimulated emission. So just now I told you that whenever the radiation is interacting with the matter, so what is happening, that absorption and emission is taking place. So whatever the absorption is taking place, you just say that is called induced absorption, and the emission, that is called the spontaneous emission and the stimulated emission. So emission is of two types. One is spontaneous, another is stimulated. So here, so we just discuss very briefly regarding the interaction of the radiation with the matter. Now what do you say, first we'll just start with the induced absorption. What is the meaning of induced absorption, right? See, what is induced? Induced means what is happening. So first of all, we just discuss our induced absorption with the help of the energy levels. You can just see that there are two energy levels, E1 and E2, where E1 is the ground state and E2 is the higher energy state. Now this E1 and E2 are, we say that this is called, this is actually the scenario when no absorption is taking place. The atom will be residing at the ground state. So we just say that E1 is the ground state and E2 is the higher energy state. So now before observing, right, the atom will be there at the ground state. So what is happening is that when the matter is interacting with the light radiation, you can just see the schematic diagram of the second one. So what is happening is that the atom which is residing from E1 has gone to the E2, which has been shown by the arrow mark. You can just see the second diagram, wherein you can just see that the arrow mark is indicating that the atom is moving from the ground state to the higher energy state, and the energy of this photon, you can just see light radiation is consisting of photon, and each photon will have the energy, that is h nu, where h is the Planck's constant and nu is the frequency of the light radiation, right. So now, so this is called induced absorption, right. So now induced absorption, again see, transition of the atom from the ground state to the higher energy state, how this atom is transferring from taking the second what you can say higher, it moving to the higher state by means of the external energy which is supplied to the atom in the ground state. Now, what is the meaning of this? See, now just now we just studied about the absorption. Now we just deal with the emission part, right? So emissions are two types: spontaneous emission and the stimulated emission. Now, after excitation, now we just know that idea. We are having an idea that the atom is at the excited state. Now there are two processes by which the excited atom, the atom which is there in the excited state, will come to the ground state, right? So you should be very much clear that whenever the atom is in the excited state, it will not stay at that particular excited state for much time. It will try to come back to its original state, that is the ground state. So in order to come back to its original position, what we'll do is that here what the important thing that we are going to do is that we'll just make the atom to travel. See, as the atom is there in the excited state, so it will try to come back to the ground state. So there are two processes which will be possible. The first one is spontaneous emission, which will be taking place in the normal conventional light sources, right? So after the excitation, the atom will spontaneously, right, instantaneously it will come back to its, there is the possibility one. See, atom is there in the excited state, and since the atom is there in the excited state, it will try to come back to its ground state. So there are two possibilities. One possibility we are just discussing. See, in the first possibility is that after excitation the atom will be there, and the atom will be there for some time in the excited state, and it will try to come back to its ground state, and while coming to the ground state, it will emit the photon. So we just say that particular phenomena by this particular second diagram, that is after emission it is emitting the, see, it is there in the ground state, higher energy state before emission. So now it will not stay for much time in the excited state. It will try to come back, and it will, while coming to its ground state, it will emit the energy, and we say that h nu energy, we already know the photons, the light is consisting of photons, and it will have the energy h nu. And how this energy will be equal to, this energy value of h nu will be equal to E2 minus E1. Definitely E2 is greater than E1, so therefore we'll just write that h nu is equal to E2 minus E1. Now this is what actually happens, right, in the spontaneous emission. Again, there is another possibility of emission, that is, we say that is called the stimulated emission. So there is another possibility that we'll discuss, that what is actually the meaning of stimulated emission, right? So now, since in the previous case we just discussed about that, now the atom is there in the excited state. So the second possibility, so what we will do is that the second possibility is that we will induce the photon here when the atom is there in the excited state. So while coming, it will emit the radiation. Again, it is emitting the radiation, but external energy is being induced on the photon. So for example, when one photon has been released here, in the case of spontaneous emission, there will be one more photon will be emitted. Why? Because at the excited state, it has been interacting with the induced photon. So the emission of the photon, whenever an atom is moving from the higher energy state to the lower energy state under the influence of the inducing, see here, under the influence, the second important case of the emission. So here, external energy, that is inducing photon. Now this is the basic principle where the laser action is taking place. It is a principle of laser action. So now this is E1 and this is E2. This is what we'll just say that h nu is equal to E2 minus E1. Now this is the case for stimulated emission. So we just say that the stimulated emission is the basic principle on which the laser action is taking place, right? So now we just say that h nu is equal to E2 minus E1. This is the case for stimulated emission. Now there are two important conditions that for stimulated emission, we need to for stimulated emission to take place, there are two important conditions that should be satisfied. the energy level where the lifetime of the atoms will be of the order 10 power of minus 3 to 10 power of minus 2 seconds, right? So that is whenever it is reaching to the higher energy level, below that exactly the atom will stay for some time, and some more time it will the level which is in between the ground state and the higher energy state, we just say that particular level is metastable state, and the atom will be staying for that particular in the particular state for 10 power of minus 3 to 10 power of minus 2 second. Now again, for this induction of the photon, we need a very powerful source of energy. We need a very powerful source of energy for the stimulated emissions to take place. Now this is the case for the what you can say laser action. Now the definition, see, so before the laser action is taking place, you need to remember the what is actually the meaning of population inversion. So just now we discussed that the stimulated emission is nothing but it is we are using an external source, right, to the atom which is there in the excited state. The photon is externally induced. So what it means actually, see, the number of atoms in the ground state should be more when compared to the number of atoms in the excited should be more, such that more number of photons can be generated, and the stimulated emission for the stimulated emission to take place, first of all the important condition that should satisfy is the population inversion. The atoms which are residing in the ground state should go to the higher energy level, and the number of atoms in the higher energy level should be more when compared to the ground state. The state of achieving more number of atoms in the excited state compared to the ground state, we just write mathematically, that is N2 is very much greater than N1, right? So we just say that is called population inversion, right? We say that is called population inversion. Lifetime. So what is like the meaning of lifetime? So very limited time for which a particle remains in the excited state. So it is about a very few seconds, that is a nanosecond, right? So now this is called actually the lifetime of the photon, right? Lifetime of the atom which is staying at the excited level. So very less time, that is nanosecond, for which the atom will be there in the excited state, right? So now, so what is the basic just now we just discussed about the population inversion. See, we are very much interested in studying more about the stimulated emission. Why? Because this is a basic principle on which the laser is working. So if you want to produce a laser, so you require some important parameters or components. So the first important component that we are going to discuss in today's class is the active medium. Now this is a basic material in which the atomic and molecular transition takes place, leading to the laser action. Now this is a basic material in which the atomic and molecular transitions takes place to leading to the laser action. Now it is the medium where the stimulated emission is taking place, and we just say that is called the active medium, right? So we require a medium where this process should take place, right? So the component that we require for producing the population inversion is the active medium. So again I'm repeating, this is a basic important component which the atomic and molecular transitions takes place, leading to the laser action, and we say that this is called laser action, and it is the medium where the stimulated emission is taking place, right? Now this is what the second important source. Now we require some external source, right? We just say that stimulated emission, you require the important what you can say external agency, external source. We just say that is called pumping source. Now with the help of energy source, the system can be raised to an what you can system, or what we just discussed about the atom. So we require some amount of energy source where the system can be raised to an excited state. With the help of this source, the number of atoms in the higher energy state may be increased, and hence the population inversion is achieved. So in order to achieve the population inversion, first of all, what is the system that we require? We require an active medium. So for the active medium is required for laser action. So in the laser action you require some induced photon means the external agency, and that external agency, the external agency from where we can move the atom from the ground state to the higher energy state, and we just say that it's called pumping source. So with the help of the energy source, the system can be raised to an excited state. With the help of this source, the number of atoms in the higher energy state will be increased, and hence the population inversion can be achieved. Now this is the second important aspect. So what are the different pumping techniques that we will discuss when we just study one by one about different types of laser, right? Now, so third important what you can say component which is required to produce a laser, any laser, right? So if I talk about laser, so I'm talking about the laser, either it may be solid laser, gaseous or liquid laser, whatever it may be. For any laser which is to be produced, require a certain components. The first component is the active medium, the second one is the pumping source. So the first one is active medium, just now we discussed, and the second one is the pumping source, which is required by the what you can say the system to produce the laser. And third important aspect is optical resonator. Now what is optical resonator? So optical resonator is nothing but consists of two mirrors here. You can just see this the schematic diagram which has been shown to you. This is the energy source. Now there are two. What is optical resonator? So the optical resonator is actually consisting, you can just see the diagram, right? At the bottom you are having the diagram where a partially, see, you can just see partially silvered mirror will be there, and on the left hand side a fully silvered mirror will be there. There are two ends. Now this is considered to be a set of mirrors, fully silvered mirror, partially silvered mirror. The set of mirrors at the ends of which are silvered, one end is silvered, that is called perfectly reflecting surface. Now, and other is the partially reflected surface, which will make the photons which will be emitted from the due to the pumping technique. The photons are emitted, and which will be parallel to the axis of the active medium, through which the atom will be excited. So under these particular, see what I told you, stimulated emission, we require an external agency, and that is called the energy source. The atom will be excited state. While it is coming to the ground state, in between that it will reflect to the what you can say fully silvered, or we say that fully reflected surface. When it is reflected, and at the left hand side where it is fully silvered, so it will be reflected, and will from the right hand side the atoms will be partially reflected, right? So now, so which are emitted and which are parallel to the axis of the active medium, and this undergoes multiple reflections between them. So the light intensity, what is the purpose of studying about optical resonator? These optical resonator will amplify, see, it is amplifying the photons, right, which has been emitted, that has been amplified, and it has been taken out from the partially reflecting surface. Now this is about the optical resonator. You can just see this solid state laser or any laser, which, see, this is Nd:YAG. We say that this is solid state laser, and this laser is having a very huge applications, right, for the medical purpose and for other purposes also. So mostly we'll just Nd:YAG laser will be used for medical purpose. So now here we just have a very clear idea what is happening, what is whatever the three components what we discussed in the just now. That is, the first one is your active medium, second one is the pumping source, right? First one is the active medium, pumping source, second one, and third one is the optical resonator. When they combine together, this is a schematic view of the what you can say how the laser, any laser which has been produced, right? So now this is Nd:YAG laser, solid state laser. Now left hand side is a very highly reflective mirror, and the right hand side will be having a partially reflected mirror, and in between that you will have an active medium, and we just say that is called the laser medium. So now this is called Nd:YAG crystal, and these are what the optical resonators, right? This is, we just say that this is the mirrors. The left hand side is highly reflective mirror, and the right hand side will have a partially reflective mirror. From here the laser is coming out. See, the laser radiation is coming out, and we just say this is called the laser output. Now, See, laser action, how the laser action is taking place. See, for any laser to produce, first of all, whatever we consider the energy levels, we require at least 3 energy levels. One is the ground state, another is the excited state, and in between that, if you find more than one state, that is one is the E3 and another is the E4. See, E1, E2, E3 and E4. So here we're just designating this E4 as the excited state. In between that, if you find that if there are 2 stops for the photon, so this is called intermediate state, and this is what metastable state, where you can just get the laser light, right? This is the output what you will get by means of the stimulated emission. And as for any laser to be produced, if it require a minimum of 3 energy levels, E1, E2, E3 and E4. So here I just discussed about the 4 energy levels. If there are 4 energy levels, well and good, right? If it is 4, it is well and good, right? So if it is 3, it's also I will show you that the 3 energy level, which type of laser can be produced, and if it is 4, so which type of lasers will be produced, right? In the next session, next lecture, we just study about the ruby laser, where I will show you how these energy levels can be utilized for producing the laser, right? So here now, for any laser action, lasing action, energy is applied to a given medium, and where the medium in which the atom or the electrons are unstable at the highest energy level. Now these atoms spontaneously come back to its right, it will decay to its metastable state, and the population inversion is achieved when majority of these atoms have reached to its metastable state. So lasing action occurs when an electron. So what is actually lasing action? Just now we are discussing. For any laser action to be occur, so the atom or the electron, right, spontaneously returns to its ground state, to original state, and produce a photon. So now if the energy of this photon is having a very precise exact wavelength, it will stimulate the production of another photon and of the same wavelength. Here the wavelength plays a very important significant role in the lasing action, which will be resulting into cascading effect. We just say that this is called the stimulation which is taking place. I will just say this is called the lasing action, and the very high reflective mirror and the partially reflective mirror continue, and the reaction by directing photons back through the medium along the long axis of the laser. The partially reflecting mirror allows the transmission of small amount of coherent radiation that we observe as the beam. We say that different radiations combine to form a beam, right? So laser radiation will continue as long as the energy is. So these type of radiations will be emitted as long as you give the external source, right? And this is the laser radiation will continue as long as the energy is applied to the medium. Now we will find that see, in this particular section we just discuss what is actually the just now discuss we discussed about the production of laser. We started with what is actually laser full form, and what is the basic characteristics of the laser, and what are the components which are required to produce any laser. And in this session, so we just discuss separately the applications of the laser. Now military, you get a very huge, I said that laser is having enormous number of applications. So just discuss about the military applications. Now for infrared camera has been used for laser continuously, which can scan up to 6 to 10 mile radius around your airport. You can just see the airport also. So in the airport we'll just use a infrared camera where the suspicious heat emissions which will be taking place, it will look after the suspicious emissions which is be emitted. So when it finds a different what you can say, if we count some suspicious heat emissions, so it will give some indication, right? There will be a tracking system where you can just give the exactly which enemy some plane is enemy plane, or some foreign device which is intruded in the region of the military, which is be designated by them as the intruder. So by this we can say that the important military application to find the exact target where actually some intruder device or intruder plane can be found in the region, and that region is extending from 6 to 10 mile, right, around the radius, right? So now, and by using the laser, the laser beam, we can just destroy the missile. So the laser beam cannon emits a burst of intense light aimed at the missile's most different spot, usually the explosive compartment. Simultaneously, it sends a signal to the airport to control the authorities to fix any problem with the origin of the rocket or the and in industries they are being used to drill very tiny holes which are present in the hard material, and it can be also laser can be used for welding and machining. And in medicine you already know that, see, laser light is being used for breaking of the gallstones, kidney stones, and your retina eye surgeries is easily done by using the laser. So, and mostly we'll use the Nd:YAG laser to detach retina. So it's a type of welding, right? So to destroy a cancerous and precancerous cells at the same time, some heat seals of capillaries, right? We'll use the laser, right, to destroy the cells which are affected from the cancer, and to remove the plaque in the human arteries. You have a clogging, and you can just remove that clogging, plaque clogging in the human arteries by using the laser. And also it is used for blood cell diameter. So we can just know the diameter of the blood cell, the erythroid cell. So, and also this can be used for fiber optic laser, which is important catheter treatment for ulcers, right? For ulcer also we'll just take the help of the fiber optic laser. So by means of the fiber, we'll just insert the laser and we can just destroy the ulcers which are present inside the body, right? And the coagulate blood, and also for blood which is coagulated, for the coagulation of the blood also we can use the laser, and can be used for dental treatment. This can be very, very important. You can just see that how these lasers have been used not only for military, for industry, and for medicine. It is having huge application. Now that is the reason that an engineering student should know the basic concepts of the laser, right? Now with this we'll just take a leave for today's class. In tomorrow's class we'll just discuss about the ruby laser and so on. Now I thank everyone for the patience hearing. Thank you everyone.